Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we would like to continue the discussion with the how to draw the cam profiles by using some problems. At the end of this lecture, student will be able to construct the cam profile for the given problem. Now we will discuss the construction of the cam profiles for different types of follower motion with different types of motions are discussed in the following example. In the first problem, first we need to identify the given data. After that, we need to identify what are the constraints. Then we need to solve step by step. We see in this diagram, in this problem, a cam is to give the following motion to a knife edge follower. So, first we need to identify what type of follower. In every problem, first of all we need to identify what type of follower it is. Generally we will have most of the thing knife edged follower. Next one we are having radial follower. Next we are having some another models flat. Next some other varieties, okay, like mushroom varieties, like this we are having, right. So, major thing is knife edged and radial. Out of this, in this problem it is given knife edged, right. The most easiest one in the cam follower problems, it is for knife edged, right. Okay. What is the data given? You see, outstroke during the 60 degrees of the cam rotation, dwell for the next 30 degrees of the cam rotation, return stroke during the next 60 degrees of the cam rotation, and the last thing, the dwell for the remaining 210 degrees of cam rotation, right. So, the 360 degrees is divided into 4 parts. Outstroke, that means rise. So, outstroke is also called rise for 60 degrees. Next dwell, so it is taking rest for next 30 degrees of the cam rotation. So, while the cam is rotating through 360 degrees, what are the different parameters that we need to observe is rise for the 60 degrees, dwell for the 30 degrees, next return for the next 60 degrees. So, the remaining dwell for remaining 210 degrees centigrade, right. So, this last one is just only a straight line we will draw to the x-axis, remaining thing is not required, right. So, 60 degrees, 30 degrees and 60 degrees, right, okay. Now, this is for 360 degrees of the cam rotation and what is the knife edge movement. So, this is one part. Next part, the stroke of the follower is 40 mm. So, what is the stroke of the follower? How much distance it is able to move from lower position to the higher position. So, in the displacement diagram, we need to draw like this. Draw a horizontal line with 0 degrees to 360 degrees. And on the same line, you need to draw a vertical line with stroke of the follower. What is the stroke here? 40 mm, right. Now, okay, so this is the 40 mm, this is one of the data we need to incorporate in the diagram. Next, what is the data given extra? Minimum radius of the cam is 50 mm. So, after the displacement diagram is drawn, then we will go to the cam profile diagram. There we need to draw the radius of the cam minimum 50 mm. On that we need to construct the cam profile. Okay, come to the problem. The follower moves with uniform velocity, right, during both the outstroke and return strokes, right. So, in the rise 60 degrees, what is the type of motion? It is uniform velocity, right. Now, in the return, what is the type of motion? It is also uniform velocity. Now, what we need to do? So, what we need to do? draw the profile of the cam when A, the axis of the follower passes through the axis of the camshaft and there is a deviation. The axis of the follower is offset by 20 mm, observe this, offset by 20 mm from the axis of the camshaft. So, this one we will discuss as a second part. So, first we will discuss about the part A, the axis of the follower passes through the axis of the camshaft. Now, we will discuss about one by one. So, first we will go for the displacement diagram. So, what we need to draw first, I need to construct a 0 degrees to 360 degrees, 0 degrees to 360 degrees. Out of this 360 degrees, so for our convenience I am not making proportionate. So, for our convenience I am taking this is 60 degrees, next 30 degrees. So, 60 plus 30, 90. So, next 30 degrees, this is the rise, this is the dwell, next 60. So, 90 plus 60, 150. So, I am taking this as 150. This is the remaining thing. Okay. So, this is the rise. Okay, I will write it another color. Okay, this is the rise, this is the dwell. Then you see, this is return. And this is the last dwell, right. Now, from here to here, so from this point to, because this is the rise, this is stroke of the follower, so this will be 40 mm. Now, the cam will rotate 60 degrees to reach the follower point, that is knife edge. Knife edge means very simply, it is the point of contact between the cam and the follower, just like I am showing my hand and I am showing the pen. So, it is the point of contact is just only a tip, right. So, just like the tip, it is also called knife edge, right. So, this knife edge follower to travel 0 to 40 mm, it is taking cam rotation 60 degrees, right. Now, okay, I will take this as the O point, this is point A, this is point B, now this is the point C I will take, and this is again point O, because it is to repeat, right. I should not take the point D, right. Again after 360 degrees, again we are coming to the same point, that is why I am taking, this is also O. Now, you look at this, O to A, what is the path it is to follow? Uniform velocity. In the uniform velocity, already we know that I can draw a straight line OA. So, this is a straight line. This is actually we are drawing displacement diagram. Now, from A to B, what is there? It is the dwell. It is dwell. The follower will not move at all, right. That means here we are having a pure arc, right. There is no up and downs. It is an arc, right, arc of a circle. That is why the follower will not move at all, right. So, A to B, it is the dwell. So, from B to C, what is this? It is getting down, the follower is coming down at uniform velocity again. So, I need to draw another horizontal line here, B to C. Now, from C to O, again it is a dwell, there is a horizontal line same. Now, I will show you, this is the first dwell A to B, this is the second dwell C to O. In both the cases, the cam profile will trace the arc of a circle. Remaining, when there is a rise, when there is a return, definitely the cam profile will be deviating from the radius, arc of a radius, arc of a circle, right. Okay, we will come to this now. After drawing this OABCO, this is actually the displacement diagram, but we cannot trace the same thing onto the chart for the cam profile. So, we need some points to trace the curve, right. So, for that benefit, what we need to do is divide this into some equal parts, right, so that your curve will be very smooth. And how many parts we need to divide, it is decided by observing the angle. So, here it is 60 degrees, right. So, I can divide the 6 equal parts, I can divide 10 equal parts, right. So, but I cannot divide, I should not divide 8 equal parts. If there is any some fraction, right, if it is the fraction, right, so I should not divide. So, I can divide multiples of the 60, right, the factors of 60, not multiples. So, I can divide 6 parts, 10 parts, 12 parts, 5 parts, right, or only 2 parts, but it is not good. As many points you have, that much of accuracy the curve you will have, right. So, for the benefit of your understanding, I will divide this into 6 equal parts. So, primarily it is 2 parts like this. I am dividing into 6 equal parts, right. So, this will be 1, 2, 3, 4, 5. This will be 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Next, the same thing, 90 degrees to 150 degrees. This is also 60 degrees. So, I am dividing this also in 6 parts. So, because this is 5 and obviously it will be 6. So, I am writing here 7, 8, 9, 10, 11. So, this will be 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, right. Now, you can observe the diagram. You can see here 60 degrees it is the rise, 60 degrees it is the rise, 30 degrees dwell, 60 degrees it is the return, the remaining 210 it is dwell again, right. So, this A, B, C, D, E, F, G, H, J, K, L, M, N, P, because O means it is starting point. So, the P up to the last. So, this is actually the displacement diagram. We need to transfer this onto cam profile. Now, how to draw this? Okay, this is actually the procedure for drawing the displacement diagram. So, we completed this, right. In our data, it is given the profile of the cam when the axis of the follower passes through the axis of the camshaft, that is one part. Second part, it is offset by 20 mm, right. So, first we need to discuss about when the axis of the follower passes through axis of the camshaft. So, how it will be here, you see, suppose this is my cam, sorry, the follower. Now, I will draw this. Okay. Suppose this is the cam and these two are, this is the follower and this is the cam. Even though the cam is having the irregularity, but there will be a shaft on which the cam will be mounted, right. So, suppose I am saying this one, this is the shaft is rotating like this, on this the cam will be mounted. Suppose I am mounting like this, let it be, right. So, if I am seeing from this side, how it is looking? So, there is a shaft centrally, on this the cam will be mounted. So, the cam will be looking like this. Okay. Now, where is the axis of the cam? Right. So, this is actually the axis of the cam. Whatever the axis of the shaft is there, the same thing will be axis of the cam, right? Because it will be mounted on this, right? So, the cam can be mounted according to the shaft, right? So, when this one, suppose in this, the axis of the shaft will be like this, maybe, okay, let it be, right. So, here this will be the axis. Actually, this axis, the vertical line which I am showing, it is actually penetrating from the axis of the plane paper, right. It is not exactly vertical, it is pointing outside, right. Actually, I need to draw like this. It is actually the 2D, right, but we need to show the 3D perpendicular to the 2D surface, right, clear. Now, here I am having some distance between the axis of the follower and axis of the camshaft. Suppose I am mounting, now I am showing the follower exactly on, where I need to draw? Exactly on the axis of the cam. Now you look at this, now this is my follower. Now how the axes are there? This is the axis of the camshaft. Now this is the follower. Both are passing through the same. Okay, even though they are perpendicular, this is the axis of the camshaft. I mean the rotating shaft. On this cam will be mounted like this and it is rotating like this. So the follower is touching like this. So this is axis of the cam. This is the follower axis. So both are intersecting, right. If there is an offset, so the axis of the follower can be something to the left or something to right side. So there may be some 20 mm, in the problem it is given 20 mm left side, 20 mm right side. So this is actually the offset. So the first case we will discuss. Now you can see here how to draw this. So this is one method. There is another method that is most easy one. Okay, both are actually the same. They will follow the same thing. The profile of the cam and the axis of the follower passes through the axis of the cam shaft is drawn as discussed in the following steps. So this diagram is not a simple one. We need to follow step by step. So first we need to draw a base circle with radius equal to the minimum radius of the cam. In the problem it is given 50 mm with the OS center. So in the diagram, so okay, I will show with yellow color, okay. So initially I need to draw this circle, right. Actually this circle is representing the shaft, right, because it is completely circular in nature, right. Next, what do I need to do next? Since the axis of the follower passes through the axis of the camshaft, therefore mark the tracing point A. So in the diagram, what is the tracing point? Tracing point means simply forget about the cam, rise, dwell, return, forget about everything. Simply the camshaft is equal to completely circular shaft, let it be, right. Then we need to mount the follower touching the surface of the cam, right. So where the follower is touching or the knife edge follower, the edge is touching the camshaft. So that is the starting point of the cam profile. It is called trace point. So the first point I need to take on the same axis. So I am locating point A. This is point A. Okay. Now after locating the point A, what next? From OA, mark angles 60 degrees to represent outstroke and SOT 30 degrees to represent the dwell, and TOP 60 degrees to represent the return stroke. Okay. So the first thing A I am identifying. Okay. This is actually the circle. So initially we don't have any other things, just only I am having the circle and point A, right. Now in the displacement diagram, what you made, you divided this 360 degrees into some parts. What is the part 1? Now whatever the cam rotation angle, the same thing rotation you need to transfer to the circle. So 60 degrees, so you draw a 60 degrees point, put the point S on the circle, right. So this AOS, so I am darkening with the blue color. So this part is actually representing, what is this, outstroke or rise of the follower. How much is it rising? 40 mm, right. Next 30 degrees. So from 60 to 30, so it is 90. So this part you need to represent, this part will be dwell. Next again another 60 degrees we are having return. So this part is return, right. So we need to identify some salient points here. This is point A, this is S, this is T, and this is P. So AOS is the rise, and SOT it is the dwell, and TOP it is the return, and the remaining part, this remaining part will be, what is this? It is completely dwell 2. Okay, it is completely dwell. Is it clear? Now on the rotation of the one rotation of the cam is to be divided into as many rise, dwell, return, rise, dwell, return, like this, right, up to 360 degrees is completed. Now that part we are making, divide the angular displacement during the outstroke and return stroke into the same number of even parts as in the displacement diagram. Just to look at the displacement diagram earlier, what we did, we divided this into 6 equal parts and 6 equal parts here. The same number you divide this AS, that means AOS angle 60 degrees into 6 equal parts. So 60 by 6, so it is 10 degrees. So on this you identify the points 1, 2, 3, 4, 5, 6. So this AOS is divided into 6 equal parts. Now each and every line you join it and you extend it. Okay, we will see here. So join the points 1, 2, 3, etc. and O dash, 0 dash, 1 dash, 2 dash with center O and produce beyond the base circle. So what is that beyond base circle? Actually, you see, we need to divide the arcs only in the case of the rise and return. So I am dividing only this part and this part. So here also I am dividing the 60 into 6 equal parts. Now I need to extend this to cross over the base circle. So I am extending, I am crossing over the base circle. Okay. So I am extending like this. Okay. Now you need to set up the 1B, 2C, 3D and O dash H, 1 dash J from the displacement diagram. So where I need to get this? In the displacement diagram you have seen, you look at this, what is the first one? This part. This part you take with the compass, transfer onto this. This part you need to take, transfer. This part you take and transfer. So after transferring each and every length, right, I will get point B here, I will get point C here, I will get D here, I will get E here, I will get F here, I will get G here. Then if you join all of this, then I will get a cam profile for the rise, right? After rise, okay, coming to the return also, I will get the same type of profile like a different curve. What about the intermediate that dwell? You take the O as radius, O at the center, and OG or OH as the radius, you join the curve like this, because this is the, when there is a dwell, the dwell part of the cam profile is definitely a arc of a circle, right? So this is dwell, right? Okay. So join the points with a smooth curve. The curve AGHPA is the complete profile of the cam. Actually we completed initially this one, next to this one. The remaining things, what are the remaining things? The dwell part. The dwell part actually with the compass we are joining like this, right? So this is also, actually this is drawn, so we need to make darken it. Okay, so this part, whatever you are having this colored portion, this is AGHPA, this is actually complete profile of the cam. The summary of this lecture is, student can construct the cam profile for the given problem conditions. Thank you.